Alright, Algebra 2 class. Starting something a little new today. I've never done this before. Tried it out for about an hour and a half now after school. I've got number 26, which is tonight's homework. I'm going to try to get this posted, maybe even in time for some of you to see it tonight, on page 192 of our book. Notice how I have the objective function up there. We're going to use that later. Don't even need that right now. All I'm trying to do right now is to show you how to convert these equations right here to linear inequalities that are correct and able to be graphed. If you'll notice right here, let's start with the first one. I converted this one by subtracting x from each side. I know that 6 minus x is the same as negative x plus 6. Whenever I have an x minus y, understand that minus y is the same thing as saying plus a negative y. I subtract x from each side. And then I have that negative y is less than or equal to negative x plus 4. Notice how I have not flipped the sign yet. After I divide by negative 1 on each side, I do have to flip the sign. When a negative comes along, you must flip it. Flip it good, right? After I flip it, I'm left with y is greater than or equal to x minus 4. I'm going to go ahead and graph that for you. First, by plotting 2 points. I know that's all I need in order to graph a line. So I'm going to go ahead and graph this one right here for us first. I'm going to go down 4, and I should have the tick marks all the way down to 4. And I'm going to go ahead and plot. Ooh, messed up there. I'm going to go ahead and plot that point. And I know that this is a function such that I can go up 1, right 1, up 1, right 1, up 1, right 1. Actually, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And that puts me right there at the point 0, 4. Notice I could have also went up 4, right 4. That's also a positive slope. Just as well as down 4, right 4 is a positive slope. I'm going to try to make this line now on the graph. So I'm going to go ahead and take this. Ooh, it's in red. Don't want it in red. Let's go ahead and grab that and make it a different color. Take it through our y-intercept. Let's strive for perfection here. So let's go ahead and take that. Again, I would like to change the color of that line. There we go. I also want to go ahead and put end caps on that line. I want to give props to the fact that it's a line. Actually, before I do that, I'm going to go ahead and extend it here because I don't really know how much of that I'm going to need. I could need quite a bit of that up there. So I'm going to go ahead and make sure it extends beyond the page. Then I'm going to put my end caps on it to show, hey, it goes infinitely forever in that direction. Over here in that magenta color, I'm going to go ahead and plot my points. Right after I mark off my x and y axes here, I can see I have 4, 5, 6, 7, 8, 9, and all the way at the top I have a 10. So I really don't have to plot any more points on there. I'm going to change my color to plot this nice magenta line. I know the y-intercept is 6. I'm going to go up 6. It's kind of tough for me to get the hang of this right now. I'm looking at the computer screen, not at what I'm doing. And I know that I could go down 6, right 6 to get to my next point. So I'm going to go ahead and do that. Down 6, right 6. And then I'm going to go ahead and draw a line by using my line tool here. I'm going to go ahead and take that line and understand it's not dashed. It is a solid line because of the greater than or equal to over there. I'm going to extend that line up. I'm just going to get these lines graphed first. Understand that is half the battle when you're doing this stuff. I would just like to change the color of that line to our magenta. Alright, and it wouldn't be a line if I didn't put some end caps on it. Notice how I've already labeled my X and Y axes. I've got those points squared away. Now I'm going to go ahead and graph X is greater than or equal to 0. Kind of a tough one to graph. You automatically want to think that's the X-axis, but it's not. Come over here. I already have the red. X is greater than or equal to 0. Well, if that were X equals 0, I know every X value would be 0. In order for every X value to be 0, it has to be a line that goes straight up and down. So it's actually the y-axis, kind of tough to fathom for some. Again, wouldn't be a line unless I did put those end caps on it. So I'm going to go ahead and do that. Some people think that it's not necessary to graph the y-axis. I'm showing you, though, because I want you to differentiate between the x and the y-axis. I'm going to come over here, and we're going to make that blue line. X is greater than or equal to 0. Well, actually, I'm sorry, that is y is greater than or equal to 0. Every y value on that would be 0 if it were y equals 0. So I'm going to go ahead and draw that line. Probably going to have to move it up a notch or two. Too high. There we go. And I'm going to put my end caps on that. Alright, now the shading part. This is one of the tougher parts for people. We're just going to go ahead and start down here. Y is greater than or equal to 0. I know it's going to be above that line. I'm just going to draw a little arrow there to remind me it's above that line. X is greater than or equal to 0. I'm going to go ahead and draw an arrow on that line as well. Remember, that's my line right over here. And I know I'm going to be to the right. So automatically, I know I'm in quadrant 1. If I'm above the blue and right, I'm in quadrant 1. Now let's go ahead and analyze this green line right here. Greater than or equal to means above. Greater than or equal to means above, so I'm going to be above this line right here. Okay, that's a pretty bad arrow. Tried to be artistic there. Not very artistic. You probably noticed this year. And I'm going to shade above that magenta line as well. And where all these intersect is where I'm going to have my feasible region, which my feasible region here actually isn't a feasible region. I'm going to go ahead and color that in now. I'm going to color that in. Let's go ahead and color that in. These are all the points that I can use in my orange function. I'm going to go ahead and color that in orange. And I know that it's going to be this right here. This is the point where all of those intersect. This is the only point that I can use. These are the only points that I want to use for my feasible region. I'm going to go ahead and show you now there are several points here of extreme significance that we're going to talk about in the next video. That would be the vertices of this feasible region. I know my feasible region does not have a max. Does not have a max. It does have a min, and I'm going to need to test those 2 points right there, which are included because of this greater than or equal to, this greater than or equal to, and this greater than or equal to. So I'm going to go ahead in the next lesson. I'm going to sign off for this one. That's how to identify the feasible region. And then identifying the vertices, that's very important as well. I do want to come over here and say, oh boy. I don't want to say oh boy. I do want to undo that though. And I want to call this right here, that's the point 0, 6. And then this right here is the point 5, 1. Okay, so we're going to talk more about these points in the next lesson.